It's your runway to the stars, your guide to spaceflight, your finger on humankind's pulse as we reach out to the stars. From the science to the fun to the human angle, the very basics to the more complex. There's everything you need to know about spaceflight in short 10-minute bite-sized capsules where you find stuff that you can boast about to your friends at a party. Welcome to a new episode of Runway to the Stars. I'm Yuri and I'm your man.
20 seconds and counting. T-minus 15 seconds. Guidance is internal. 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. Liftoff. We are liftoff.
Runway to the stars, to the stars. Liftoff from runway to the stars, runway to the stars.
Welcome to another episode of Runway to the Stars. Today, we dive into extravehicular activity in space, more commonly known as spacewalk. Let's first look at why astronauts were made to step out of their spacecrafts. Russia sent the first human into space. Yuri Gagarin went up on the 12th of April 1961 for the very first time and made one orbit around the Earth in 108 minutes. He was the first space hero, but then there have been a few more. Americans too started doing the same thing. Tens of Americans and more Russians went up and spent more and more time orbiting the Earth, doing the same thing over and over again. Launch, orbit, return, repeat. That's all we thought astronauts were doing. But something else was brewing. Both Russia and the United States were in a race into space. So to establish their presence in outer space, they had already thought about setting up orbiting space stations. Then, America announced it was going to land a man on the moon and return him safely to the Earth. More and more satellites were being launched. Space would soon be the future, and scientists and engineers soon realized that future astronauts will have to leave the safety of the spacecraft and float into open space for various reasons, whether it was to repair something outside the space station or to walk on the moon and collect moon rocks. As if going up in a fire-breathing rocket was not dangerous enough, now they wanted astronauts to come out of the rocket and float in the air a few hundred kilometers above the Earth. And rightly so, they had a few doubts. Could a human survive in the vacuum of space? Would they be able to move their limbs and move around? Would they become disoriented? Would they need to be protected by special pressurized suits? Could they do any useful work while wearing those pressurized suits? And most importantly, once they got out of their spacecraft, could they get back inside to come back home? So then, how did they actually make this happen? Now, these kind of experiments normally begin on the ground because thermal, altitude and pressure chambers can to some extent simulate the conditions in space. So they put astronauts in these chambers, and suits with pressure and thermal protection were tried out. The tests suggested that it was possible, but nobody knew for sure. They just had to send someone up and see it for themselves. And that's when some more space heroes happened. Hats off to the first few guys who tried it in the early 60s and proved that getting out and floating in open space was possible. They survived and they came back home to tell the story. It was 18th March 1965. Russian cosmonaut Alexei Leonov slipped into his pressure suit, opened the hatch of an inflatable airlock and came out of his washguard spacecraft. For the first time, a man was floating in space along his spaceship, hundreds of kilometers above the Earth. An extremely important milestone in the history of spaceflight. He stayed out for all of 12 minutes that almost ended in near disaster. The moment he stepped out of the spacecraft into the vacuum of space, his suit started expanding, just like a balloon would expand if you suddenly put it in vacuum. It could have burst. It became so stiff that he could barely move inside the suit. It had expanded so much that when he wanted to come back into the washguard, he couldn't fit back in through the airlock hole. So he thought outside the box, and that's what astronauts are known for. At great risk to his own survival, he managed to open a valve on his suit and release a major portion of the breathing oxygen he was carrying with him. That deflated the suit to some extent, and he eventually squeezed himself back inside the spacecraft. 3 months later, American astronaut Ed White ventured out of his Gemini 4 spacecraft and stayed out for 23 minutes. He had similar problems, but to a lesser degree. He also carried a handheld gas-powered maneuvering gun to move around. His suit, though, was better and didn't inflate that much. Matter of fact, he loved the experience and didn't want to end his walk in a hurry, so he was ordered to stop what he was doing and forced to get back inside. But these first few spacewalks did prove that humans could work outside a spacecraft. Though to put it mildly, moving and maneuvering in space was not easy. It also showed how dangerous the environment was. More spacewalks followed and more astronauts got an opportunity to experience this thrill. They learnt more lessons, and over time, the suits were modified and made better to the extent that astronauts were now spending 6 to 8 hours outside their spacecrafts. And then, of course, the Apollo landings, where 12 Americans spent hours outside the spacecraft exploring the rugged surface of the moon. The last Apollo mission's crew spent over 22 hours on the lunar surface. Extravehicular activity, that's what they called this time spent outside the spacecraft, and it evolved from a daring experiment in survival to a routine but risky part of working in space. Today, astronauts are doing much more, repairing satellites, assembling space stations, as also conducting scientific experiments outside the spacecraft. In one case, the Hubble telescope developed a problem after launch, so astronauts went up, walked out of their spacecraft, and repaired it. The Hubble is today one of the most successful scientific experiments ever launched into space. Even the International Space Station, for instance, when they conceived it, they realized that it was too big and too heavy to be launched from Earth in one piece. So the various modules of the ISS were launched one by one, separately. Again, astronauts went up, connected all these individual modules 400 kilometers up in space, installed solar antennas, routed power cables, and did all that was necessary to make it happen. The ISS has been the largest EVA project till yet and has been in orbit for over 25 years now, all thanks to our spacewalking astronauts. So how do they do it? Let's see how astronauts go out and stroll around in open space. Well, it most certainly is a very hostile environment. The temperatures vary from extremely hot in the sun to extremely cold in the shade. There is no atmospheric pressure and they are in a vacuum. The lethal space radiation is constantly bombarding them. To guard against the elements, they put on these special spacesuits that protect them. The suits guard the astronauts from extreme temperatures and radiation. But there's another big problem there: the vacuum and the total lack of atmospheric pressure. So these suits are also pressurized. The pressurized spacesuits, however, do not provide the comfortable pressure that the astronauts would feel normally inside the spacecraft. The pressure in the spacesuit is much lower. So when the atmospheric pressure being felt by the body is suddenly lowered, the nitrogen dissolved in the blood and tissues separates and forms bubbles inside the body. This leads to decompression sickness, severe joint and muscle pain, dizziness, and in severe cases, even paralysis or death. So how do you avoid this from happening? An astronaut, before coming out of the spacecraft, is made to breathe pure oxygen for a couple of hours. This reduces the nitrogen in the body, which drops to safe enough levels and does not do any harm to the spacewalker. An astronaut is also normally attached or tethered to the spacecraft with a cord called the umbilical cord. Just like a baby's umbilical cord, life-sustaining, it's actually the astronaut's lifeline. It supplies the oxygen to breathe, the electricity to power the spacesuit, cold water to prevent overheating, communication wires, and of course, keep the astronaut from drifting too far away from the spacecraft. Though the suits are slowly evolving towards reducing the reliability on the umbilical cords now, the life support systems are built into the suit, and the astronauts even have small nitrogen-powered jetpacks to help them maneuver themselves back to the spacecraft in case they drift too far away. Let's now take a look at how they train astronauts for a spacewalk. Of course, a lot of training is required to leave the spacecraft and do the work outside. So how do you train? Because it is not possible to simulate that environment on Earth. They found the closest option: train them underwater. NASA built a huge swimming pool called the Neutral Buoyancy Lab, and with some clever manipulation of weights placed inside the astronauts' suits, they managed to keep them floating in the same place underwater. Almost the kind of feel they would get when floating in space. That's as close as they could get, and astronauts quickly became good at it. Many hours are spent underwater at the Neutral Buoyancy Lab during an astronaut's training schedule to get proficient and qualified for a spacewalk. India's very own human spaceflight program, Gaganyaan, is going to be up there very soon. And though no Indian astronaut has ever been trained for extravehicular activity yet, we will need spacewalk-trained astronauts soon, because just like the International Space Station, India has planned the Bharatiya Antariksh Station to be up and running by the year 2035. It takes a few years to assemble a space station, and a long training period before that. So the process of selections and training for the Indian Astronaut Corps should be starting in the next few years, and EVA training will be an important part of it. And as space travel extends to beyond low Earth orbit, modern EVA techniques will have to be evolved. Astronauts of the Artemis program will soon be walking on the moon after more than 5 decades. Extravehicular activity will have to be done in lunar orbit and on the lunar South Pole, where conditions are entirely different. We will also be exploring asteroids and eventually trying to survive the weather on Mars. There you are. The next few years are set to prove that human presence for extended periods in outer space is highly possible. Moving, working, and surviving outside the spacecraft's safe environment will help us create permanent stations and live and work in space, on the moon, on Mars, and who knows where else. What began as Alexei Leonov's risky 12-minute experiment has become an essential skill that enables humanity's presence beyond the Earth. In our next episode, we look at distances in the universe. How far are the planets? How far are the stars? How far is far? Don't forget to tune in. And here's a fun fact to blow your mind.
This will blow your mind. This will blow your mind. This will blow your mind.
In 1984, American astronaut Bruce McCandless was the first to fly in space without the umbilical cord. He held a nitrogen gun in his hand, which fired like a jet whenever he wanted to move in space. That image of him flying unattached to anything is one of the most iconic pictures in the history of spaceflight. And before I go, a little question for you. Who has logged the most time flying outside the spacecraft? Who has logged the most time flying outside the spacecraft? The answer in the next episode. In the last episode, the question was, who was the first human to orbit the Earth? And the answer, of course, Russian cosmonaut Yuri Gagarin. Thanks for listening. I wish you blue skies forever.